Pradeep, does it make sense? Yes or no? A quick yes or no on the chat window. Sure. Okay. Pradeep says yes. Emily says yes. Sure. Thank you. Thanks everyone. So I assume no other questions from the yesterday's session. Let me move ahead with the other things. I'm sharing my screen. So everyone can see my screen with the did I get? Sure. Hi Pawan. Yeah, I can see you. So Pawan, we were just before you joined in, we were just talking about yesterday's session. We were just discussing what we did yesterday, doing a little recap of that. Do you have any questions from the yesterday session? Anything you want to ask, or anything which you want to share about the yesterday session? So I'm just going to start with the next things. Oh, Pawan says no. Sure, fair enough. So let's go ahead. So we talked about the replication engine. We talked about the heartbeats. We talked about the heartbeats. We talked about the task trackers. So let's look at how really write happens in the system. So when a write need to be happened in the system, the file a file is divided into blocks, and or a client sends a request to name node to add a block. Name node returns the location where that block need to be written. The localization always taken care in this scenario. The first data node which would be returned for this write anatomy would be a local node if the client is sitting on some SDFS cluster or SDFS node. If that is sitting outside the SDFS node, then that first data node could be decided randomly, as we discussed yesterday. And then the second and third would be on some other racks and things like that based on the locality and considering the network topology defined in the Hadoop cluster. So yesterday someone also asked whether this can be changed or not. So now I'll explain you. So this all the data nodes which are returned are based on the network topology which is defined in the cluster. There is a default topology defined, but you can definitely change those topologies. And once you change the network topology, the data nodes which would be returned by the name node might differ based on the distance calculated based on the network topology defined in your configuration things. Then that write signal or the data is written from the client to that data node, and then that data node, the first data node really writes or copies the data to the second data node. There is a not direct communication between the name node or client to the second name node. So sorry, second data node. The communication happens from the first data node to second data node, and then the network which is used is from the first data node to the second name node. Second data node. Name node never comes in the picture in whole write framework. The second data node will send a write or copies the data to the third data node. Third data node will send acknowledgement to second data node. Second data node will send an acknowledgement to first data node, and first data node will send an acknowledgement to your client, and client will send a complete signal to name node. And this is the way name node gets to know that data has been written completely. Any guess if while copying the data from first data node to third data node, or second to third, first to second or second to third, the data corrupts in between, then in that case what could happen or what should happen? Or say while copying,
it would stop the, I'll take a shot at it. It would stop the heartbeat to the name node, so then it would go to a different server.
Yeah, Emily, you are right, but my question is a little different. What I was saying is, say a data which is copied from this data node, it sounds like this. What I was trying to ask is, say I have given a write signal for writing the data, and my data is just say single character A. It has copied to this data node. Then this character has been copied to this data node also. But while reaching this data node, there is some issue in the network, and my data got corrupted, and instead of A, it became B over here. Due to some network issues, due to some issues in the network, my data got corrupted. It instead of A, it might become some junk character or something like this. It became a junk character. In that case, how that is defined or how that could be achieved in the system. So Pawan says, get to know about the heartbeat. Yeah, Pawan, that is fine. I'll be coming to that easier question also. My question was right now, if say data got corrupted. Jignesh says a perfect answer. Checksum, yes. So with the data, we also copy the checksum. Checksum is nothing but Jignesh, do you want to explain what is checksum?
I think checksum is just computed signature or count of the bytes that are being written. So just validating the number that is being transmitted from each node as it writes.
Yes, perfectly fine. So with the data, it's not only the data which is copied, also with the data, the checksum is also copied with the data, and the data storage capacity is not increased more than 1% while adding the checksum to the header of the data. And with the help of checksum, data nodes get to know the data which they have received is correct and there is no network issues have caused the data corruption. And in that way, the data checksum happens on each data node, and once the third data node does the checksum and finds out whether data is correct, then only it will send an perfect or completed acknowledgement signal to the second data node, and so happens from the second to first and first to client. Now, yeah, now my next question was, I think Emily, you were trying to answer this. If say while copying the data, the second data node goes down, while copying the data from data node 1 to 2. In that case, what could happen? Yes, Emily, it stops heartbeat. Heartbeat signals would be stopped sending to name node, but what would happen to the write signals? How the data would be written? Name node sends the task to different file. Yeah, okay. Yes, that is how it happens. So basically, the data node 1 will copy it directly to Jignesh. Time now it will not happen over here. The data node 1 will try to copy the data to third node and will send an acknowledgement which states that the data is not correctly copied, and the name node at the back end will give a signal to one of the nodes which has a perfect copy to copy it to the third node to maintain the replication factor in the system. Does it make sense?
Can you explain again?
Sure. So Jignesh says the name node holds all the metadata. Yeah, Pradeep, name node holds all the metadata. It only holds all the metadata. So here, if say this data node goes down, in that case, it will give a write over here. It will send an acknowledgement over here. It will send an acknowledgement over here. It will send a complete, partial complete over here. And at the back end, name node will give a write signal to this data node or to this data node. And this data node will then write it to some other data node to maintain the replication factor of 3. Make sense? So I think that was Jignesh who asked that question.
Right. So the first data node who is writing to the second data node and second data node failed, how does the first data node will know about it to send it to a third one?
So over here again a communication happens to the name node. When it tries to communicate with second data node, it will not be able to communicate to the second data node, and it has the location where all the copies of this data need to be copied. So it has the location where all the copies need to be copied. So if it is not able to communicate with the second data node, it will try to communicate with the third data node. And an acknowledgement would only be a part of third data node and the first data node in this scenario. Make sense?
Okay. Okay, so that means when the first write signal comes to first data node, it knows which other two data nodes to send
yes.
signal.
That's only is happening over here, because if it does not knows where it has to send, then this whole framework cannot exist, because over here name node is not coming in picture. Name node has given it at this point where to write it, and now the writing is happening over here, and we are not communicating to name node in this whole write picture.
Okay, got it.
Okay, so this is how the really write happens, and that's the reason when in my previous slide about the blocks over here, when I was saying the blocks, that's the reason behind it. Now you can understand it fully. That the first copy has been copied over here, and the second and third copies are simultaneously placed on the same name node, and this is how we save the network bandwidth, because really the data is copied from here to here and here to here, and this is less costly effort, and that basically helps in our system to reduce the network cost. So this is called data pipelining in the system. Oops. So this is called data pipelining in the system, and I just discussed everything what is written on the slide. You can, if you want, you can just quickly read it, or I'll go ahead. I've discussed everything which is written in the slide. So this is how the read happens. When I, as a client, I have to read some file, I ask the name node where the blocks are lying. Name node will return me the positions where blocks are lying, and it will just send me a group of blocks that these are the nodes which are having the group of the block, and here again the locality is taken consideration. So name node will try to return the blocks or the data nodes which are most local to this client, and from where it can read. So it will return him the list of data nodes which have the blocks, and the client will then keep on reading those things from the corresponding data nodes. Pretty simple. Okay, yeah, this is the thing which I was talking about, checksum. This is how the data correctness is taken care in the system. So there is a protocol. I'll not go into the protocols and things like which is used to do the checksum, and checksum is nothing but a kind of signature of your data, and that helps the system to maintain and find out if the data which has been placed or the blocks which are lying in the data nodes are correct or not. At the back end, there are other threads also running in the system which keeps on sending the checksum computation of the blocks which are lying on the data node, and that helps understand the name node that the data which is lying on that data node is still perfect and fine. If this thread which is running and doing the checksum calculations on the blocks which are lying on the data nodes sends a signal that the data has got corrupted due to n number of reasons, then name node at the back end sends a signal to the nodes where the data is correct for those blocks, because it knows by the same thread where the checksum is perfect for those blocks. It gives a signal to those data nodes, and the data from those data nodes is then copied to some other third data node, and when the data copy happens perfectly fine, and then the name node sends a delete signal to those corrupted blocks, and then those corrupted blocks are deleted from the system. Make sense to everyone? A quick yes or no, a quick heartbeat from everyone will make me understand whether everyone has got it or not. So if I'm saying or not, you can periodically send me the heartbeat signals, and that help me understand you are getting it or not. So how is the name node? Pradeep says, so how is the name node related to the job tracker? Pradeep, name node is now related to the job tracker. Job tracker is a process which is running, which could run on the name node, but there is no hard and soul rule that it should run on the name node. Job tracker is a separate process which maintains the jobs which are submitted to the cluster. Name node is a major, is a Ferrari of the system which maintains the whole cluster. That is a Hadoop distributed file system. Job tracker is a process which is running in the cluster to maintain or to help your process. So basically, it's a monitor to monitor to all your processes or the jobs which you submit to the system. Pradeep also says, or does the job tracker sit on the name node? Job tracker can sit on the name node, yes, but there's no hard soul rule. You can run job tracker anywhere else in the cluster, but please ensure that on the node on which your job tracker is running is a good performer node, high performance node with good hardware configuration, because job tracker is a heavy process which will be maintaining your whole cluster, so that should not be a commodity hardware. Make sense, Pradeep? Pradeep says yes. Okay. So that's all from this slide. We'll be moving on to the Mapreduce. Anything you want to ask? I'll just open another slide. I'll pause the screen for a minute. So by the time, if you have anything to ask, just ask me. I'll open the new slide. So guys, before moving to the Mapreduce and the SDFS, interacting with SDFS thing, let me talk other things also before going ahead. So yesterday, my today, but tomorrow, but yours yesterday or your today early morning, I have shared. What is the main change? Jignesh, I have a separate slide for Hadoop version 2, that is the yarn architecture. I'll be discussing about that, but try to understand the Mapreduce word prior to that, how you interact with the SDFS thing. I'll cover the yarn part in a separate session. Don't worry about that part. Okay, there is a dedicated slide on yarn. There's a difference rather than job tracker and task tracker. There is something called application manager which manages your application. So the criticality in this system is if your job tracker is down, all of your system, the processes which are the jobs which are running in your cluster are down. You don't have any other mechanism to regain those jobs. Although there is an option in Hadoop cluster which says persist the job tracker state kind of thing, but that does not work perfectly fine in the cluster. So to come up with these kind of things and other things which we'll be talking about, there's something called application manager. So rather than a single job tracker maintaining all the jobs across the cluster, an application is initiated for each job, and it's the responsibility of that application manager to maintain the job. And if that application manager goes down in the cluster, it's only one job which has gone down. Other jobs are perfectly running fine in the system. So that has been beautifully designed with the help of application managers and things like that. We'll talk about that thing in the yarn architecture. For a time being, just wait for some time, and probably the next week I'll be explaining that thing in detail. Okay, so I was saying that yesterday I have shared some files on Google Drive. So those of you who have shared me the Gmail IDs, I've shared it on your Gmail IDs. Otherwise, I've shared it on the email IDs which you have shared with me. So there are, just give me a sec. So there are softwares inside that folder which I've shared with you, Hadoop softwares. I hope everyone has received that email. If anyone has not received or not able to look into that shared folder, just ping me now on the chat window, please. Okay, Pawan says I haven't checked yet. You can check it, not a problem. Anyone else have not received it? Okay, I got it. I'm just, Pradeep says he got it. He's just opening it. So guys, you can open at the back end. These are, there's a GBs of data lying over here. You can download that and I'll explain you how to do the installation and things like that in this class. And we'll also be looking into how the Mapreduce works and how the cluster, how you interact with the SDFS world. So I'll just explain you what I'll be talking about, and I'll one by one I'll also be helping you in the installation of all these things. So Pradeep said he got it, he is opening it. I'm just waiting the similar replies from everyone else, whether you have got it or not at least. So here I've shared a few things. Those from the Java background can easily understand it, but those not from the Java background or those not from the Unix background might just listen to me. So here I've copied two things, WinSCP and PuTTY. PuTTY will be Jignesh, PPT is the PPT which I'll be keep on putting into the PPT folder as soon as we'll be covering that topic. So that topic, Hadoop Basic, was almost done. So I've placed into the shared folder. As soon as I'll be covering the new topics, the PPTs related to that topic, I'll be keep on putting into that shared PPT folder, and you can view those PPTs over there whenever you require in the future. So that PPT folder will remain same till the end of our session. All the PPTs which we'll be covering in the class would be placed into that folder once the topic has been covered, and you can copy it from there. And there's a separate folder which I've shared in a separate email called Hadoop Software. The email would be from designpathshala@gmail.com. So this Hadoop Software folder is the folder where I've shared a lot of software with the people. So here, WinSCP and PuTTY are tools which help you in doing the SSL or FTP to your other file systems. Then there's a folder called VM. So here I've copied the VM image and the Oracle VirtualBox. So Oracle VirtualBox helps you virtualize your environment to the to the Unix environment, where this Hortonworks Sandbox OVA is an image of pre-configured Hadoop node, and this node has everything, name node, data node in a single node, a single node cluster, and it has all the software installed in it. So all you have to do is just install this Oracle virtual machine and import this OVA. I'll be talking in detail how that is done, and I have pasted a document also over here. If you face any issues, you can just look into this document installing the VM. And then when we'll be looking into the Mapreduce world, there's Eclipse which we'll be using to write the Java programs. You can download the Eclipse if you don't have from here, based on the 32-bit or 64-bit machine you have. Now I also share the JDK. If you don't have the JDK, just copy it from here. And Maven we will be using for building our jar files. We can directly build it from Eclipse also. I'll show you people, but those who want to use Maven console, I'll be using Maven for building it for the sake of easiness. So I'll just place it over here. Why it's the VM you said? You are saying this. Okay, so this is not exactly a VM, Pawan, you are right. So actually, we keep on using the VMs only for installation and those things. So that is a buzzword which automatically comes out of our mind. Sorry for that. It's not exactly a VM. This is just a virtual box, Oracle virtual box, where you can load your sandbox and you can run it. It's not exactly a VM. Sorry for that. So actually, we keep on using the VM. So our clusters are virtual machines, and we connect to them. So it's in a habit of me to keep on saying them as VM. I'll show you how we interact with the Hadoop. So this Oracle VirtualBox I have installed on my So when you double click this Oracle virtualbox.exe and install it by clicking next, 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 it will look something like this. These things would not be visible to you. But then when you download that OBA file which is lying just next to this exe file and click on File, Import Appliances and import that file, just browse that file and import that and click on Next, 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 you will be able to see this Hortonworks Sandbox Studio over here. Once this is imported over here, you have to right click over here and click on Start. Start is not visible right now because this sandbox is already running. And when the sandbox starts running, something like this window comes up, and for 5-10 minutes you can see some code which is getting initialized. There are a lot of software which get initialized and started up. It might take 5 to 10 minutes on your laptops based on your laptop configuration and things like that. But when this is fully up, you will see a screen something like this, where it says started on localhost on port 8888, and you can do SSH to this machine on port 2222. So first download these things, then in the next class I'll discuss in little bit more detail if you are facing any issues on installation and or while configuring it. Let me for a time being just connect to this sandbox and show you how we interact with the Hadoop-based file system. Okay, so this is a Unix console which I have opened with the help of PuTTY. So what I did is, just a sec. So what it is when I open PuTTY, there's a different version of PuTTY which I'm using over here. Don't worry about that. But when I open PuTTY, it looks something like this, which is there on the right hand side of this box. And here I give the localhost and I give the port on which that machine is listening, and I just connect to that. And when I connect to this machine, it will ask me for the username and password. The username to connect is HUE and the password is Hadoop. You can write it down. I am repeating it again. The username is Hugh and password is Hadoop. And when you open this, so this is all configured in my laptop. So it has not asked me for the prompted me for the password that was stored, and something like this opens up. Pradeep says Hugh and Hadoop. Yes, Pradeep. HUE Hugh is the user and HADOOP Hadoop is the password. Everything is small. So I'll talk a little bit more detail how to install that and what issues you could face in installing. But let me throw some light on how to interact with the Hadoop-based file system before going over there. So when I log into this machine, I can run. So this is a normal Linux box which you can where you can type on your commands. So if I say ls, I can see the folders and things like that. So how to interact with the Hadoop world? So for interacting with the Hadoop file system, my command should be starting with something like this: HADOOP Hadoop and FS. So this says I am interacting with the Hadoop file system. Hadoop space FS. This says I have to interact with the Hadoop based file system, and then I have to give options to this command what I want to trigger. If you don't remember the options, you don't have to worry about. All you have to do is just type Hadoop FS and press enter. It will give you all the options which are visible with this command. So there are a lot of things which we can do with the Hadoop file system command. As we are talking about Hadoop file system, so these are the things which are possible with Hadoop file system command. So if I have to look into Hadoop file system, what are the files in my Hadoop file system, I have to just type Hadoop fs -ls and root. So this will give me all the directories which are available at the root location in my file system. So guys, now you can understand, I hope everyone understand what is happening at the back end. My client, this is my client on which I am triggering the command and at the backend what is happening. Do anyone want to explain what has happened at the backend when I've triggered this command Hadoop fs-ls? Although it's a single node cluster, but what has happened at the backend? Can anyone do anyone want to answer this question?
It lists out the name node directory.
Yes, and then? So I on this Unix system is a client which is sitting locally on some data node. For a timing, just assume that, and the name node is somewhere else. Just for a timing, assume it's not a single node cluster. I am sitting on some data node. And now I have triggered this command Hadoop fs-ls / that is, I'm just trying to list the directory to the root position. What has happened at the backend? Now Pradeep, it will not list my data nodes. I am listing the files. ls is the command to list the files that is in the Unix, and same almost all the commands which are what it signifies in the Unix word, same they signifies in the Hadoop word also. All you have to do is prefix them with Hadoop fs that tells or my system that I'm interacting with the Hadoop file system. So Hadoop fs prefix with any Unix command, not any Unix command, but the commands which are feasible with this listed over here gives the interaction, or basically interacts with the Hadoop file system. So Jignesh, you were correct. It will only interact with the name node. There is no other interaction which is required for this command, because here I am not really reading any data. I'm just looking into the metadata of the system. So as I'm looking only at the metadata of my system, so there's an interaction with the name node. Name node returns what is the directories or what are the files at the root location, and those files or that list is printed over here. So there's no other communication happened over here. But if I say Hadoop fs -cat, let me look at some file first. /temp. I'm just trying to find out any file to cat. Oops, there are a lot many. Oh, sorry, the directory. It's empty. Oh, I did not say it at just 0 bytes. Sorry, I did not say it. Yeah, there's a file. So now when I'm getting this file, I'm printing this file on the console. What has happened at the backend? So this has printed me whole file. So at the backend, what could have happened? Do anyone want to explain me what has happened at the backend behind the scenes for you when I've triggered this command? Hadoop fs -cat and the file. I'm trying to read one file from the Hadoop based file system. At least try to give some answer. You might not be perfectly right, or you could be perfectly right. Just try to answer, think of what has happened in the backend.
So it pinned name node to find out all the blocks for this file, and go to the data node, one of the data nodes where all the blocks are one by one, and print it.
Yes, definitely. So that has happened in the backend, and that's all transparent to us. So we are not worried about. So what I mean to say, yes, you're perfectly right. So what I mean to say over here is everything, all this complex algorithms, all this complexity of the framework is transparent to me. I, as a user, don't have to worry about all these things. Don't have to worry about the checksum of the data. Don't have to worry about if the data is replicated properly or not. Don't have to worry about if some data node is down. Don't have to worry about if the data transfer issues, network bandwidth issues, anything like that. Everything is transparent to me by the beauty of this framework. All I have to do is I have to just interact with the Hadoop file system as the way I interact with any other file system. I, as a client, it's all transparent to me. So let me show you other commands which are there in the Hadoop file system. So if you press Hadoop FS enter, you can see other commands also. So cat, I hope you understand. Chmod, chown, all these things. I hope you understand. If anyone of you don't understand anything, just let me know. CP is to copy the command. So either you can use move to local or move from local. Move to local or move from local to copy the files here and there from the SDFS to your local system, or from local to SDFS. Or there are other commands similar to this called put and get. So put and get also do the same thing. I can put a file into the SDFS file system, or I can get a file. Pradeep, I'll just come to your part. I can use put and get. So put is to put a file in from the local system to Hadoop world, and get is to get a file from to the local system from the Hadoop world. So Pradeep asked a question which is Pradeep, your question is pretty big. Let me read it. You listed the content of the file. So as a question, cat is a simple command. If I write my own program, say bird search, will I invoke it using Hadoop FS minus bird search variables? No, Pradeep. You can definitely invoke it n number of ways, but it will depend on you how you want to invoke. If you want to do some search on a file, you can directly use the console. You can write your Mapreduce code to search on the data which is lying into LCFS word. You can use the layers above Mapreduce like Pig or Hive to search some data inside your file system. So that will depend how you want to do it. How do you want to do search? But this is one of the way to interact with the file system.
So Meeraj, can you hear me?
Yes, I can hear you.
Okay, so I guess the question that I was trying to get at was, what you're trying to show us is, you're trying to show us a system which is, you're trying to show us a system that is an HDFS system, right? I mean, all the data nodes and all the data nodes they have the HDFS file system on it. So you're trying to show that example, and then you ran one simple command. Cat is a standard program that you ran to list out all the files, right? So I guess my question is, the entire purpose of putting data in the HDFS system is so then you'll be able to have programs go at this data in a parallel mode and be able to work on it faster, right? I mean, that is the entire concept of this. So what I was trying to get at was, if we'll obviously write more complex programs that we want to go and search for the data and work with it. So those complex programs, will we always call them using that structure that you gave us? You said Hadoop FS, and then you said a minus or something, and then you call the program name. So is that how it will always work, was what I was asking.
Okay. So Pradeep, this is just a command. Hadoop FS says Hadoop file system. So this is a command just to interact with the Hadoop file system. There are other commands like, so if you just type over here Hadoop and press enter, it will give you an option which are other commands supported with Hadoop. Hadoop FS is the one thing which I just showed to you. There's something called Hadoop ZAR. So this is the way I'll be submitting my job. So Hadoop ZAR. And the ZAR file name which I have created, the ZAR which I was talking about in one of my slides, how to submit the job. So any jar if I have, and will give the parameters if I require to pass to this program. and I will just press enter. So this will at the back end will send a signal to a job tracker, and job tracker will then communicate to your task tracker and perform the task for you.
Okay, perfect. Thank you.
Yeah.
So that's what I was missing. So it's the Hadoop jar and then the name of the jar file.
Yeah. So this
Okay,
is how I'm submitting the data and the configuration about the about the logic and the configuration about the logic, and this is how that need to be submitted. So I'll be coming to this part when I'll be discussing about the Mapreduce. So sure. Okay.
Thank you.
Okay. So this is the simple way I can communicate with the Hadoop file system, that is Hadoop FS, and I can put or get any files from the Hadoop file system to my local system also. So say if I'm over here, I just move out somewhere, ls, I'll just move to logs, ls. So here, these are the files over here. Now what I have to do is I have to get some file from the Hadoop file system over to my local system. All I have to do is Hadoop fs minus get / user / use / input / text.text. I think this was the file name probably, and I want to get it to the local directory. So I just says get and the file name which I want to get. So this is a Unix. No, so this is not the correct path. So let me cross check what was the path which I've given in the previous command. Okay, so this was so I say get this file, and here I want to get this file. So this is location in HDFS, and this is a local location. So what I'm trying to do over here is I'm trying to get a remote file or a HDFS file to my local system. And so here is a file, text.text, and same way I can put it. To put it, I have to just give put, and any file which I want to put. So I want to put password.log, and where I want to put. So it will put at that location. So this is how I can put or get the files directly from Hadoop file system from my client. Also, you will not be using these mechanisms to put and get the files, but this is one of the way. So Hadoop fs minus ls output, and here's the file, and here's the file. So here I've placed the file into HDFS, and from here I've copied the file from HDFS. Similarly, there are other commands also. So you can just read them one by one. If you don't understand any of them, do let me know. Or you can just look into the help. This is a pretty common command. RM will help you to remove the directory. RMDIR is again to remove the directory. RM for remove the file. Recursive for removing the whole directory. RMDIR for removing the whole directory. Tail is to tail the file. So touch is to touch the file, and all these Unix commands. So all you have to do is just prefix Hadoop FS prior to those commands to interact with the Hadoop world. Okay. So let me go back to this box. Where's it gone? Just a sec. Sorry. Okay, so this just wait for this machine to start up. When this machine is started up, based on your RAM configurations and your system configuration, your system might also get slow, and you have to bear with that because this is a heavy process which will be running on your local laptop. So whenever you are trying to run this virtual machine on a laptop, you can either close all other programs which are consuming high RAM because this program will require at least 2 to 3 GB of RAM. If you have 8 GB of RAM, I will request you to grant it more than 2 to 3 GB of RAM so that it can run perfectly fine. Otherwise, it will run a little bit slow. So, and over here with the help of Putty, I'm interacting with this sandbox. So just try to install it over the weekend, and then we can look into your respective laptops and desktops if you're facing any issues while installing it. Probably you will not face any issues while installing it. It's pretty simple to install it. But to import it, you have to just click on import and import the file. I've also pasted the installation document. Just try to go through it, and if you face any errors, there is one particular error which you might face. If your laptop has firewalls, blocked or things like that, and there is an option how to enable that. I've just written in the same document. Go through it. If you face any issues still, do let me know. We can discuss that thing in the next class. So let me move on to something else. So guys, this is one way how I interact with the system. Second way is the Hue UI, how I can interact with the system. So this Hue UI is, so Pawan says yes. Pradeep says 2 to 3 GB RAM in our laptops. Yeah, Pradeep, it will consume more than 2 GB of the RAM which you have in your laptop. So please close any other processes which are running on your laptop prior you start this sandbox. So mine, I'm easily able to fluctuate over here and there, and I'm able to open the Eclipse also. And the reason behind that is I'm running everything on the 16 GB RAM. So there's another thing which I want to talk about before going to that slide. So other way to interact with the Hadoop-based file system is the Hue UI. So all you have to do is just type on your browser 127.0.0.1:8000. 8000 is the port on which Hue UI is. This UI would be visible to you. I pinged everyone on the chat window the URL. Pradeep says I need a new laptop. Okay, Pradeep, yeah, probably if your laptop is 32-bit RAM, 32-bit laptop, I request you to change it to 64-bit and add a little bit more RAM to run it, please. So, but you can try it on your laptop. It will eat your RAM, and you would be able to get the results. Those will be slower, so you have to bear with that. So Hue UI Jignesh is pre-configured for you. So as I was talking about different flavors of Hadoop, Hortonworks, Cloudera, and things like that, Hue UI is available by default in Hortonworks flavor. And all you have to do is, if you are using Hortonworks flavor, all you have to do is open 127.0.0.1:8000, and Hue UI will be open for you. So it's a pretty good UI by which you can access the whole cluster. So when you will open this 8000 port, you will be given a form to fill up. Fill up that form once, and next time it will not ask you to fill that form, and click on submit or thing next or something like that, which will appear on your screen. And prior to that, it might ask you for the username and password also. And username and password. Just look on the UI. There somewhere on the UI, username and password is written for you, the default username and password. If you are not able to figure it out on the UI, ping me on or email me. I'll let you know. As I can recall, the username is Hue and password is probably Hue only, but that is stored on my laptop, so it has not asked me. If you face issues with this login, do let me know. I'll let you know the correct password. But when the screen will open, it will ask you for the password. Somewhere on that same screen, the password would be visible to you. Somewhere it would be written the default password and things like that. Just try to read the whole screen. It will be written somewhere on the top of the screen. and the password would be written over there. The user would definitely be you can use, and the password is probably password or Hugh, but I cannot recall right now. So Zignesh says okay, thanks. So everyone else, are you able to follow me? Is this making some interest to you? I'll just move on to the Mapreduce world also in next few minutes. But is this making sense to everyone? So Pawan, Jignesh is continuously giving me questions. Pradeep is continuously giving me questions. So these are kind of heartbeat signals to me, which makes me know that you are available in the system. So Pawan says, what is the UI? I missed, I got diverted, sorry. So Pawan, I was talking about the Hue UI. So this is a beautiful UI. If you don't like those black boxes, if you don't want to interact with that black boxes, you can use this UI to interact with Hadoop files, Hadoop-based system. When you open this URL 127.0.0:8000 and press enter on your browser, you will be some pretty good UI would be visible to you. And first time it will ask you a form need to be filled. You can just fill that form, press on submit, and then it will take you to a login page. There you have to enter the username and password. Username is Hugh, and the password, the default password, is written on the same screen somewhere on top of the username, or somewhere near about there. You can just look over there. If you don't figure it out, do let me know. I'll check what is the default password. I don't remember it right now, and you can log it. So we can do all the tasks that we do in Putty in this UI. Probably yes. Pawan, you can do almost all the tasks. I'll just browse you through this console, and that will give you a brief about this console. So here on the front screen, you can see it talks about the different processes which are running in the cluster. Hue, Hadoop, HCatalog, Pig, Hive, Uzi, Ambari. What is Ambari? Don't worry, I'll talk about that. HBase will not be covering in this whole session, but there is a NoSQL database which is also there enabled for you. So here are consoles also to interact with different systems. So this is a Hue UI. So this is a Hive UI. Here I can write the Hive queries. This is a Pig UI. Here I can write the Pig queries and can submit them, execute them. This is HCatalog. HCatalog is a meta store for Hive. I'll talk about this thing in detail when I'll be covering the Hive part. This is your really file browser. So here I can look into the file system. So if you remember, when I press ls root, these are the folders which are visible to me, and when I've gone to temp, these are the folders which are visible to me. So this is how I can browse the directory UI directly from here. And I can look into any file. I can open any file directly from here. So say if I want to open this file, Design Pathshala.test, this file is visible to me. I can even edit the file by clicking the edit button. I can type something else. I am changing this file and click on save, and at the back end everything has happened to you, and this file is saved in the SGFS file system. So this file is changed. So other than that, you can the most beautiful thing about this UI is, at least for the developers, you can upload the files directly from your Windows file system to your SGFS file system. So all you have to do is click on File, select File, and select any file, open it, and it will be placed into your SGFS file system. You can create the new folders from here. You can change the permissions. So permissions are same as your Unix world. You can change the permissions of a file or a directory directly from here. You can copy the files. You can move the files. You can rename the files. You can rename the directories. You can do anything. So this is a pretty good UI. Those who don't like the black console, those who don't want to type much, they can use directly this UI to interact with the Hadoop-based file system. this UI also has other options. This is a job browser console where I can see the jobs submitted to my system. The history of the jobs also visible over here. The current state of those jobs and things like that. I'll show you in some time. Then job designer I'll talk about later. Uzi console I'll talk about later. So this is the again view shell. So the console which I was talking about there, where I've connected with the putty, the same console is here also. I can use any of those consoles and I can type the command directly over here. I can type the command directly over here. So this is the console available here also, and then the user admin. This is the administration for the users for this View UI. So this is the whole View UI looks like. Anything you want to ask? Anywhere you want to go me a little bit more deeper before I switch over to the PPT. So for all this checking the tries. Yes, Pradeep, you would be requiring this VM for looking into all the stuff which I'm showing you right now, and for that you have to install that Oracle VirtualBox and import that VM into that. So Pradeep was asking, do we require to start this VM before we can look into this? So I was just answering him, yes, we definitely require to start the VM before we can look into all this stuff. So we can use the same IP. Sorry, Pawan, I'm not able to get your question. What do you mean by you can use the same IP when we download? Yeah, by default it will start on localhost only, that is 127.0.0 on your machine also, and you can use it if you are facing any issues while starting it up. Just a sec. Just a minute. Just a minute. Is it gone? Just a sec. I wanted to show you one more thing. Just give me a minute. So yeah, so what I was saying was, I hope you can look into the Oracle VM VirtualBox Manager, which I've displayed right now on here. So Pradeep is asking a question whether the IP would remain same for you. Yes, Pradeep, the IP would remain same for you, but in case you people are facing some issues while logging to this machine from the putty, what you have to do is right click on this this VM which you have installed right now. Stop it. Once you stop it, right click on it and click on settings. And there's something called network in this machine. Just listen to it. You might require it. Just click on networks, and this one network adapter would be enabled to you. You can just switch on to the next network adapter. Right now it's disabled for me because my VM is because my sandbox is running. But when it's stopped, it will be enabled for me to change it. I just enable this network adapter and make it host only adapter, and click on OK. Don't change anything and click on OK, and rerun the machine. In that case, there is one more adapter which is open to your machine, and your machine would be running. So basically, you're listing on two different IPs. and if you press ifconfig over here, so here I am, it's on 192.168.56.101 also, and 127.0.0.1 also. So I can use any of these IPs to connect. So right now I'm just using 127, but if you change your network adapter settings, you can add more adapters to where and you can link to them also. Is that all clear? Anything? Any other questions from anyone?
Vikram here. So is this Hugh some kind of a default user? Or?
Yeah, Hugh is a default user which is already configured for you in this pre-configured sandbox. But when you'll be installing, when your administrator would be installing Hadoop cluster, at that time he'll be creating different users and for you in the real environment. But this is the predefined user for this Hugh console as well as for this sandbox. You can add the users, you can change the users, you can remove the users, all those things you can do. But for the first time login, you can use Hugh and Hadoop as a password.
So I have a question, two questions actually. What you're using right now is Hortonworks. So the HDFS implementation or the version that you're using is that of Hortonworks, is that correct?
Yes.
Okay. And I also asked you another question. You don't necessarily have to answer that right now, but if at some time possible, if you can, and if it is okay, would you be able to tell me like how many data nodes and how many name nodes do you have? Like what specifications are you running on the background?
Okay, so this is a sandbox which is running on a single node, which I'm showing you the examples, and I'll be showing you all the examples on this. And the beauty about this cluster is, beauty about this whole framework is, the program which is running on a single node will run perfectly same on the cloud, will perfectly run for 1 MB of data, and will perfectly run in a similar fashion for 100 terabytes of data. But what we are using in our production clusters is pretty high configuration. The total RAM in my current production cluster is 1 TB. Total RAM across the data nodes is 1 terabytes. That is the pre-development cluster is a 10-node cluster kind of thing which I am working on. I'll show you some of the real clusters also, how they look like. But from the interface, how to give the commands, that is almost same. You don't have to worry about anything. You submit the command, whether it's a cluster or a single node VM, single node sandbox like this. It's almost same. I'll show you the cluster also in one of my sessions. The cluster which I'm using.
Thank you.
Sure. So your clusters could be anything. You can your administrator could be deploying it either on VMs, either on some rented hardwares like from Rackspace or something. They might be using their own hardwares, but the probability of that thing is very less unless you are working for some secure banks. So there could be different ways, but the beauty over here is whatsoever you are writing or whatsoever code you are running, that would never change irrespective of the cluster size, irrespective of the data size, irrespective of the flavor of open source Hadoop. Okay. So, let me go back to the PPT now. So I hope everyone can see my PPT. So these are a few commands which I was showing you on the Hadoop when I was running on the Hadoop cluster. MKDIR, everyone knows it. LS, LSR, port, cat, RM, everyone. I hope everyone knows now each of these commands. And I have perfect Hadoop FS with each of these commands, and that way I am telling the system I am interacting with the Hadoop based file system. Now this is a simple program which is written in Java, which I'll just discuss with you. That helps you. So although if you just want to skip this part, we can skip it. But I'll just request you to listen to it, so that gives you an idea at least, and that's there in your head somewhere, the backend. If someday you want to interact with the file system from the Java program, you know, yeah, there's something like this exists, and you can at least think or Google that thing. So I request you to listen to this, even if that does not make much sense to you, before I move into the Mapreduce world. And before I move into this program, shall we take a quick 10 minutes break, or shall we take a 10 minutes break after we discuss this program? After, Pawan says after. Okay. Jignesh, before that there are two answers, after and after. So let's take it after this, and let's look into this. So there's a package available available to you, which is Hadoop FS, orgfh Hadoop FS. So if you look into the files available in this package, there are files which helps you to interact with a Hadoop based file system. I am not talking about what's all available in this file system package. I'll just give you an example, but there's a lot of things available. You can look into them in detail later on. So what I'm doing over here is I am creating a file system object and giving the configuration to this, and I'm creating an SGFS file system object. When I have to create a local file system object, I just say file system.getLocal. So these are two objects which I have created. One is a local file system object, and one is the Hadoop based file system object. And with the help of these objects, those of you who are not from the Java background, I think Emily is not from the Java background, and there was one more person, probably I think Pawan, or was it Pawan or someone else? Okay. So Pawan, if you don't understand anything, or Emily, if you don't understand anything anywhere, do let me know. I'll try to explain as best as possible I can. And just bear with me for some of the Java code. I'll not be discussing Java code after in this class, and I'll in the next class after that I'll not be discussing any Java code, but just bear with some Java code in at least 2 classes. So that helps you people, other people, and you also to get some idea about how everything is happening technically at the back end in these systems. So Pawan, wherever you don't understand, just bring me up also. So what I'm doing is I have created file system objects of Hadoop based file system and local based file system, and with the help of these objects, what I'm doing is I'm just saying local.list list status, where I'm getting the files is in this directory, and I'm creating an SGFS file with the SGFS object, and what I'm doing is I'm reading local files one by one over here in this for loop, and basically merging the output of all these files into a single file and writing it to the SGFS world. So here out.write is basically writing it to the SGFS world. So this out is output stream to SGFS world, and input is the input, all the input files in my local directory. So what I'm doing is basically merging all the smaller input files in my local directory and creating a bigger file in the SGFS world in this example. So here what I did is I created 2 objects, input and output. From the input files list, I am looping through all the files which are in my local directory. I am opening file one by one in this for loop, and I am reading that file over here and writing the bytes which I have read from the file directly to the SGFS world, and this is how I am interacting with Hadoop based file system with the help of Java world. So we have seen the 3 ways to interact with the SGFS file system. One I have shown you the command, 3 ways. One I have shown you the command line option where I have given Hadoop FS command. The another is Hue UI, a beautiful Hue UI, and the third one is this Java program. We'll just run this. So Pawan said carry on, I think a few minutes back. So we'll just try to run it and see what happens at the back end. So this is a normal Java command which I'll be running up. So guys, all my Java development I'll be showing you in the Eclipse. Anyone of you have never seen this Eclipse UI? Anyone of you have not seen this Eclipse UI? You just ping me yes or no.
I've seen it.
Sure. So Vikram, you definitely would have seen it. Pradeep definitely would have seen it. Pawan, Pawan I think just now said he's seen it. Jignesh, what about you? Looks like he's away. Oh, Jignesh says yes. Okay, Emily. Okay, cool. Oh, Emily also says yes. Okay. So this software is also again shared in the Google Drive. You can just download it, and there's a file called when you will download it and unzip it, it will look something like this. I'll just show you. It will look something like. So it will look something like this when you download the Eclipse in the Google Drive shared softwares. Unzip it, it will look something like this. So you don't have to do anything. Just ensure that Java is installed in your PC. If Java is not installed, go to java.com or just Google download Java or install Java. And the first link from the Sun site, you download the Java and it will install it for you on your laptop. And once the Java is there, just double click this eclipse.exe, and this Eclipse will open for you. Then after that, I'll be sharing this whole project with you people. So the examples which I'm discussing in the class is available to you to run at later on at the backend for you and for your future reference also. So when I've shared this project, what you have to do is okay, there's a little complexity in this project. I'll share you another project also. Those who are not aware of Maven, I'll separate two projects in the projects folder, which I'll be sharing with you people. So those who are not related to Java, those who are not related to don't want to go into the complexity of Maven and things like that, use a project named not Maven, and those who are into Java world and can bear up with the complexities of Maven, import a project called Maven. And those who are in the Java world, I don't have to explain to them how to import a Maven project. But those who are not from the Java world, I'll just quickly tell you how you have to import this project. So to import this project, all you have to do is click on the file option, click on import, and click on and type Java over here. Oh, sorry. Click on existing projects into workspace, click on next, click on browse, go to the folder where you have downloaded the project, which I'll be sharing you again in the Google Drive, and just press enter, and something over here with the project name will be visible to you with a checkbox. Click on finish, and once you click on finish, something like this Mapreduce or Hadoop will appear to you, and it will have all these files visible to you. So once you open this program, so what I was talking about in the previous example, so this is a read command. So before going to that, let me show you this. So what I'm doing over here is I'm getting a configuration object from the file system, and this is LG-based file system. So in the configuration, I've set the default namespace of my cluster. The default namespace of this sandbox is sandbox.hortonworks.com:8020, existing on the 8020 node. 8024. So this is the config. This I've set in the configuration. I am creating an object of HDFS with the file system.get configuration, and now what I'm doing is I'm just in the input to the args, I'm giving a parameter, some input file, and I'm just printing that file to the console. So what I'm doing is I'm opening that file which I've given as a parameter in my arguments. Arguments is nothing. Argument is a parameter which you give while running this command or running this Java program, and this argument is passed to this Java program, and this argument we are reading over here and creating a file for this argument. We'll be passing this argument to the while we are running this program. And here I'm just doing what I'm doing is I'm just reading the file. I'm creating the file object, opening that file from the SGFS file system and reading that file and printing that file on the console. So for people who are not from the Java background, how to create a jar, what you have to do is just click on File, click on Export, click on Runnable jar. If you don't find it, just type Runnable over here. Click on Runnable jar, click on Next. Select the main class which you want to run. So here this main class is not visible to me. If main class is not visible to me, that is d.sgfs, what I have to do is I have to just register that in over there. So I'll just right click it and run as run Java application, and it will give me an error. Don't worry about the error. But now when I'll click on File, Export, Runnable jar, Next, and click on this drop down, that will be visible to me. So what was the name? Read SGFS. Why it's not visible? Sorry. Here it is. Read SGFS. And here I have to just give the directory where I want to put the jar. So here I have given some directory, and I am just choosing package required library into the generated jar and click on Finish. So when you click on Finish, it will create a jar and that will place in this directory which you have browsed over here. So once I create this jar, what I do is I use an FTP kind of browser. Just a second, I'm just opening the. So I open this, I use this FTP WinSCP browser, which is again there in the softwares folder. All you have to do is download this winscp.exe, double click it. Some window will open up. It will ask you for the username and password and the IP address to connect to. The IP address will again remain same, 127.0.0, and use of same username and password, that is you and Hadoop. And on the right hand side, you are able to see the Unix console of that sandbox, and on the left hand side you can see your Windows or your Apple Word. Now the jar which I have created, I have to go to that folder and drag and drop that jar into your Unix Word. So just drag it and leave it over here, and that will be copied into your Unix Word. So once you copy the jar into your Unix Word, that would be available for you. So I've copied that jar which I've created right now, that is Mapreduce snapshot.jar. That jar is packaged all the other programs also. So what I have to do is Java -jar and give the jar name and the file whichever I want to read. If you want, you can sorry, I was giving Java jar. Sorry, this is not a Java jar. This is a Hadoop word. Sorry. So what you have to do is Hadoop jar name and the parameters to this. So I'm just giving any file which I want to read. So I'll just copy this thing only. So let's say I want to read this file which is lying in the Hadoop word. So I'm just saying Hadoop jar name and the input file name. When you're so here I have not created an executable jar. I have to give the fully qualified class name. It would give me an error over here because I have not given the fully qualified class name. But when you are creating an executable jar, you have to just give the fully qualified class name. You don't have to give this fully qualified class name. So, and we can read the data. So see, it has printed me the whole the file, which all of the file which was lying in the SGBus word. So Pradeep, you have typed a big question. I'll just read your question. Give me a minute. I'll read it. So this is how I interact with the Hadoop-based file system from the Java world. So there are three ways which you have seen right now. One is the Unix Hadoop FS, one is the UI, and one is the Java world. Now these are three ways we can look into the Hadoop-based file system. There are some other ways also. We will look into them. So Pradeep is an question. Okay, so you are explaining about non-conventional data files. How does this related to say DB files in traditional RDBMS? Pradeep, would you like to read it?
Yeah. So what I was saying was, the examples that you're showing us, right? Most of or all the discussions that you have been talking about have been like conventional operating system files. It could be like a picture file or a text file or something, where then you're saying that the programs that you write will be able to go at this data in a parallel mode and be able to process it faster. My question, I guess, is from a database like your Oracle database, they are also files, but they have this data in a really structured manner. So is Hadoop type environment used for processing data in those systems also? If yes, how does that work? I mean,
don't switch over to the processing. I request you just wait for Mapreduce part. I'll be moving on to the Mapreduce part in the PPT. That's the next thing which is waiting for us in the PPT.
Okay.
Just wait for some more time for the. So this is the Mapreduce part. Yeah. So data flow. That would be interesting to everyone. I'll come to that part, but before that, I just wanted to show you how the Hadoop looks like and things like that before switching on to the Mapreduce thing. So I know that is an eagerly awaited thing, but just wait for a few more minutes and I'll switch on to that part.
Okay, thanks.
Sure. So similarly, I was showing you people one more example and then I'll move on to the PPT. But before that, I'll need a break also. I need a glass of water. So I'll just show you one more example which I was opened over here. So here what I'm doing is, this is a normal program which you people might have to run. Here what I'm doing is I'm again creating a file system object, a local file system and the Hadoop based file system. I am listing the directories which are there in the local directory. I am creating an SGBus file system object. I am looping to all the files in my local directory with this variable, reading those files and printing those files into the SGBus bus. So I am creating a big large file from a smaller files in the local directory. Now do you want me to run it or you can run it? So at the end of all these programs, I have given the hint also how to run this program. And in the just a sec. In the software folder which I'll be sharing, in the code folder which I'll be sharing with you, there on the top of that folder I've shared this jar which is already created for you. So if you don't want to go into complexities of creating the jar, you can directly use the jar, import into your sandbox and try to run these programs if you don't want to go into the complexity of creating the jar. Otherwise, these projects I've also shared with you are lying in this shared drive. I'll be sharing this folder with you soon after this class, and you can download these projects and try to burn your hands trying different examples and then play with that. So do you want me to run again this program or is that okay? Anyone wants a yes? No. Okay, I'll assume a no from everyone in that case. Okay, then let's take a quick 10 minutes break. I desperately need a glass of water. And then we'll be back in 10 minutes and then we'll be looking into the Mapreduce world, how the really data processing happens. Sure. Okay then, I'll be back in 10 minutes, and you can also take a quick 10-minute break. Hi, I'm back. So just please ping me if you are back. So Jignesh is back. Jignesh, I'll just wait for others also to back, and then we'll move on to the Mapreduce word. Anyone else back other than Jignesh? Anyone else back? Looks like Pawan is arrived. Anyone else back? Just ping me on the chat window if you are back. Pradeep says I'm back.
Hi Miraj, Pawan here, I'm back.
Hi Pawan.
Miraj, I'm downloading those softwares from the drive. It just says Hadoop softwares.html. Is that right? Because I don't see anything.
And
No exes or anything.
this is a whole folder. If you that is shared on the Google Drive. So if you go into the Google Drive and there's an option to download the whole folder, which will be visible to you somewhere. Just download the whole folders.
Yeah, I did.
The HTML is nothing but that is I think the HTML code of the UI of this browser which is downloaded for you. If
I
you
see Hadoop softwares 6 items.
yes.
And when I click on it, I can right click and save on it. I don't see a download option.
Just a minute. Let me just cross. Just a minute. So if you just select that folder or exe and click on more on top of the on this page, in the more there's a last option called download just above remove. Don't click on remove, please. Just above remove there's an option called download, and that will on the more. So Vikram also says back. Are you able to see that?
No, I'm checking.
Sure, you can check. Emily, are you back? Emily, are you back? Looks like she's away. Okay, then let's start. She might join in between. She says she will be away for some time. So let's look into the Mapreduce word with the most awaited thing, how the data is really processed in the system. So till now we have seen how the jobs are transferred across the system, but how this Mapreduce framework helps in the data processing. So as I hope every one of you would have got some clue, there's something called map side, and there's something called reduce side, or there's something called mapper, and there's something called reducer. So there are definitely two things which runs at the back end for you, which do the real data processing. So mapper phase basically maps your input to a corresponding key value pair and send it to a reducer phase. Reducer phase reduces or finds out the corresponding keys or filters out your keys or does an aggregation or segregation on your keys and the values which are available to the reducer and produces the output. Everyone understand what is key value pair? Anyone who does not understand what is a key value pair? Is my screen shared or paused? My screen is visible? Hey guys, just ping me yes or no. Is my screen visible? Pawan says okay. Okay, I'm doing something only. I'm trying to change the screen. That's saying the screen is paused. So let me try again. Just a sec. Is it visible now? Okay, Pradeep says yes. So hopefully it would be visible to everyone else. So yeah, it was giving me an error that my screen is not shared or something like that. So I was just wondering. So I hope everyone understand what is the key and value pair. Anyone says no for this? Please ask me, because if you don't understand what is the key value pair, what is hashing, what is how the key value pair really works, then you will not be able to understand the whole Mapreduce workflow. Bhavan says no. Okay. Anyone want to explain what is key value pair to Bhavan? Okay, so Pradeep says I kind of understand, but specific context here will help. Okay, guys. So all your data which you read from your which you read for processing is somehow converted to key and value pair. Here key could be anything, a value from the data which uniquely represents that data which is getting processed, or a particular part of the file which is getting processed, and that the data is passed to your mapper phase in a key and value format. mapper does some logic on that function. I'll just come on to that part. Just try to listen this and just try to understand this slide and then ask me the questions. The key and value pairs are passed to the mapper side. Map do some mapper side. There are some logic which is applied on those key and value pair. After those logics are applied to those key and value pairs on the reducer, that those are sent to the reducer. Reducer then reduces them, do some aggregation on those on the outputted data from the mapper and produces the output. And this is how the whole framework works up. Try to just listen these two slides and then ask some questions because I can't explain each and everything in my first go. I'll just try to explain you slowly. So I'll just switch back to the slide in a minute. So this is my data on left hand side, which you can see. This is my data, and my data is say that these are the blocks of my data, or I could say this is the data which is there in a block or distributed across the data nodes. What I have to do as a user, I have to calculate number of blue blocks in my data, number of red blocks in my data, number of green blocks in my data. I as a user have to calculate number of blue blocks, green blocks and red blocks in my data. So what I'll do is I'll create a key and value pair of my data. By key and value pair, what I mean is I create some key which uniquely represents my data which I want to process. So here my key would be the color. So say so what I'll do is I'll produce or pass on the data to my mapper function in such a fashion that mapper receives something like this. Key and its value. So basically the mapper function receives key. Key is nothing but the color, and value, that is the count of that box. So it receives a key and value pair. Then there's something called short and shuffle phase that is transparent to you. I'll just come onto this phase. But what mapper does is mapper produces. Okay, let me. Before that, does anyone understand what is hashing? Does anyone understand what is hashing? No. Okay. Okay. So basically what happens is the keys produced from the map side goes to some reducer. But in between magical short and shuffle phase, the similar keys are guaranteed to reach the similar reducer. So the blue color key, all the blue color keys which are produced from the map phase will definitely reach the blue color reducer. And same happens to the red color and same happens to the green color. So this happens with the help of this pre-hashing or in between short and shuffle phase. I'll just come to this part, what is hashing. So but all the blue color keys which are produced on the map side will go to the reducer, to the reducer which is processing the blue keys. The red one will go to the reducer which is processing the red keys, and green will go to the reducer which is processing the green keys. And this will happen from all the mappers. So whatsoever is the mapper, the reducer will receive the keys which the reducer is processing. And when the keys reaches the reducer with the magic of this in between short and shuffle phase, the key and the array of values reaches the reducer. And the reduce side, what I'll do is I'll just sum up these values and produce the output as color, 100. So that is the count of the color which is produced by the reducer. I'll repeat this whole thing again. Try to understand it. Try to digest it. If you don't understand it, do let me know. I'll just switch over to the hashing part also in a minute. And let me open Excel sheet. There I'll be able to explain it more thoroughly. Okay, so what I was saying is, say this is my data, blue color, red color, blue color, red color, green color, red, green, blue, and so on. And this is the block. This is one block. This is another block.
We can't see your screen, Viraj.
Okay, just a sec. Now can you see? Okay, you can see. So what I'm saying is,
Yeah.
Sure. Okay. So say this is my data, and the different colors represent different blocks. So what happens is I keep on read each record from the block. By record, I mean to say a logical data from the block. And this logical data is passed to your mapper in key and value pair. So say here I don't have to create any key because I'm just reading the data. So say the key is some magical number. I'm just giving some magical number to my data. So it produces something like this. So say any magical number which is a key, because the key is not relevant while I'm passing this data in this phase, but keys makes relevant in some other examples which we're looking on. So here say my key is passed on to the mapper functions like some magical value for the row, or say just the row number. So something like this will be passed on to the mapper. And so on. A single mapper will be called for your block. Do remember me to explain the split after I explain this part, because then now the split will make sense for you. What is split? And so on. So a mapper would be called for each split over here. I'll just come to that part. And a map function would be called. So this will be an input to your mapper, and a map function would be called. Me in a map function, what I'll do is I'll just create a key of a color. So I'll create a key of blue type and produce the count of that. So what I'll do is I'll produce something like this. So something like this I'll produce from the map phase. For each color I'll produce a key of color and value as the count of the color. Some magic happens in between sort and shuffle phase. What this sort and shuffle phase does is, based on the hash key of your key, hash value of the key, it sorts your keys and assigns those keys to the reducer. Say in the previous example I was showing you, there are three reducers running to produce an output of this program. Reducer 1, reducer 2, and reducer 3. This is your blue color reducer. This is a blue color reducer. This is your green color reducer. And this is your red color reducer. So what this sort and shuffle phase does is, based on the hash value is nothing, it could be any unique value corresponding to your key based on the hashing function. Hashing function could be anything, I can define a hashing function as sum of ASCII values of the characters of my data. So in that case, the hash value of blue would be sum of the ASCII values of B plus sum of the ASCII value of L plus sum of the ASCII value of U plus sum of the ASCII value of E. So hashing function is a function which tries to hash your data in and gives a corresponding unique integer value to your data. And that is used to sort your data to the buckets, and those buckets are nothing but your reducers. So here the short and shuffle page will try to produce all your blue colors with an equivalent hash value. So say that the hash value of the blue color is generated in the system is 44, and for the red it says generated 45, and say for blue it's generated 44, for red it's 45, for green say it's 46. So these are the different hash values which are generated in the system. Then blue is 44 and 44. 44. So say these are the hash values of different colors. So based on this hash value, our data is equivalently given to the reducer which is taking care of that range of hash value. So say this reducer, the blue color reducer, is taking care of hash values 1 to 44. This green color, this green color reducer is taking care of hash values 45, and this red color reducer is taking care of hash values 40 greater than 46. So in that case, all the hash values which are of less than 44 will go to the blue color reducer. All the hash values with the 45 will go to the red color reducer, and all hash values greater than 45 will go to your red color reducer. So this hashing helps me bucketing my data. By bucketing, I mean to say my data By bucketing, I mean to say my data is given a particular value in such a fashion that goes to some particular bucket, and there's a reducer which is listening on that bucket, and that reducer's responsibility is to process that data. So with the help of this bucketing, I get a pretty good thing. One pretty good thing which I get is the values of a particular key will definitely reach some reducer, and all those keys similar which have same key irrespective of fact from which mapper it has been produced, that will go to the reducer which is taking care of that bucket. So irrespective of the fact this green key has been produced from mapper 3 and this green key has been produced from mapper 2, this has reached the reducer number 2 only. So this is the beauty of this in between short and shuffle phase. There are other beauty also of the short and shuffle phase. I'll explain slowly those things to you. But this sort and shuffle phase, this in between hashing thing, helps me send my data to my corresponding reducer which is taking care of those keys. So in this way, I am able to parallelly process my data across the mappers, because each mapper is created for your each block, and say for a time being block size is equivalent to split slice. I'll just explain after this what is split. And so I am able to create number of mappers in my system, and when the data is processed by the mapper, the data is given to the reducer which are again running parallel in my system, and these reducers are producing the output. So this reducer will produce an output. So this blue color reducer will receive key something as blue and one comma 1 1 1 4 ones. So it will receive the key and the array of values. Similarly, the green will receive green and the corresponding pair list of values. So say there are 3 only, probably 2 only, and so on. And this reducer will basically sum up these things and produce an output something like this. And so on. Does till now it makes sense to everyone? Any questions till now before I go ahead? what is happening in this mapper and reducer phase, and in between sort and shuffle phase. There's the sort and shuffle phase, as the name signifies, it also sorts your data. I'll talk about that part also in some time. So Jignesh says yes. Does everyone else agree with this, or any questions till now? Is it is making sense till now? Vikram says good so far. Okay, I'll assume the same from everyone else. So this is how your mapper and reducer phase works. And what I'm keep on saying split till now is, by default the split size in my system is equivalent to your block size, but split is a logical division of data and block is physical division of data. So what I mean by physical division of data and logical division of data, I'll explain you in some time. But split is a logical division of data, and a mapper is created for a split rather than block. By default, the split size and block size are same in my cluster. I can change them, but changing them, if I change them, if I increase the split size to 2 block size, I have to pay cost. What cost? Say what I did is, now you understand there's a mapper for each split. These green, in this cluster, say the split size is equivalent to a block size. So this is one split, this is second split, and this is third split for each block. For each block, S1, S2, S3. What is logical division? I'll just come to that part. Now you understand at least this thing, that there's a split size which is equivalent to the block size, and a mapper will be created for each split, and the records of that block would be sent to mapper one by one. Mapper will produce a key and value pair out of those records, and those will then go to the corresponding reducers which are processing those keys, and reducer will produce the output to the STFS system. By default, the split size is equivalent to the block size, but I can increase the split size, I can decrease the split size. Does anyone want to guess what are the disadvantages if I increase the split size from 1 block to 2 blocks? Say I create a split size of, instead of one, what I say is a split size of 128 MB rather than 64 MB. So this is my split and this is my split 2, because there is no other third block. So my split 2 will be something like this. So can anyone think of what could be the disadvantages of this thing in SDFS world? Anyone want to guess? Guys, at least give me some answer.
You repeat the question. I'm sorry, I'm not sure I completely got your question. What is your question?
Okay. So what I'm saying is, the mapper is created for each split rather than block. There's an interface above block, what we call a split. A split is a logical division of data. What I mean by logical division of data, I'll come back to that point in some time. But over here, what I'm asking is, a mapper is created for each split. So if I say by default the split size in my cluster is equivalent to the block size, and in this example we have seen 3 mappers were created. This was the map 1 of somewhat gray color, or what we call this color. The second mapper was created for of yellow color, and third mapper which is represented as orange color over here, which were equivalent to a block, because I have assumed that a split was equivalent to the block. But say I have changed the configuration in my system and created and changed the split size as 128 MB rather than 64 MB, the default block size. So a split would be created for 2 blocks, and there will be a single mapper for 1 split. So a single mapper would be processing two blocks in this case. And as there are only 3 blocks, so there's a split. Second split is just processing the this block only. Or if there would have been one more block, then second split would look something like this.
Yeah. So if you do that, I'm assuming here that if you do this,
and there's a single
hashtag.
Mapper. This is a single mapper for this, and this mapper is this is a single mapper. In that case, so these are the two.
Right. So since there is only one mapper, per split, if we don't have enough number of splits, then the data, I'm just theorizing here, then the data will not be characterized properly. I mean, like, so in this case, both the blue and green, they'll all become in the same bucket, right?
No, you are not going to the correct point. I think Jignesh pointed out performance. Jignesh, could you please elaborate? What do you want to elaborate what you are trying to say?
Sure. So what I was thinking is, if you have a good enough split, then you can do more parallel operations to speed up. So if your split is large, then it has to finish the whole thing before it goes to reducer. Right?
Yeah, you are coming to the point, but what I was thinking of is still not clear. So Emily, I'll reply it back to your question over to you over the email. I've read it. I'll reply back to over the email. Sure. If you want to leave in between, you can definitely leave. I'll help you with that part, definitely. So the first disadvantage, if you recall in what I was saying in the previous sessions, is this is your block 1. This is your block 1. This is your B1. This is your B2, and so on. And this is your B4, B3, and this is your B4. Now, if these are the blocks, they will be sitting on some data nodes. So if this B1 is sitting on data node 1, the probability of B2 sitting on data node 1 is not that high. It could be sitting on data node 2, and this could be sitting on data node 3, and this could be sitting on data node 4. What I'm typing. So if this is sitting on data node 4 and this is sitting on data node 2, and I have a single split for these two blocks, then this mapper would be running on either data node 2 or data node 3. And if this mapper, this orange color, or what color we call it, I am not that good in colors. So this orange color mapper would somehow have to get this data block from, if it's running from data node 3, if it's running on data node 3, this mapper, then there will be whole data transfer of this block from data node 4 to data node 3. So to reduce these kind of network uses, it's preferred to use block size or split sizes similar to your block size. However, this is a configurable thing. You can change them, you can increase them, you can decrease them. But this is a suggested thing. There could be advantages also which you can see based on what you're looking for, what you're looking into the program, or what you're trying to achieve with the Mapreduce program. But this is one of the disadvantages which you will get when you increase your split size or double your split size from the block size. Make sense? Jignesh, split size is default by the block. Yes, it's configured in Hadoop configuration. Hadoop configurations. I'll show you those things also. I'll show you those things also in our next class. But everything is configured from the configuration files in the Hadoop world. So Pradeep, I'll just place you on mute. So this is this. Now, what's the logical distribution? I'll explain you when I'm explaining another example. But is this quite clear how this whole mapper and reducer things works? Vikram, yes, you can define it, but in that case, you are creating mappers which are basically two JVMs processing your data lying on the data node, and you are creating the overheads of initializing your map and mapper function for the localized data, and the overhead to initialize your mapper and reducer and all this bookkeeping process, which is initiated from the job keeper to task tracker, job tracker to task tracker, could be higher as compared to the processing which you would achieve in such a scenario. So Vikram has asked an interesting question: can a split size be smaller than the block size? So I was just trying to explain him. Okay, so let's go back to the PPT and I'll explain it in more detail. And so I am not going deeper inside. I'm trying my best to go as slowly as possible into the Mapreduce world. I'm just trying to go as slowly as possible. But wherever you don't understand, do let me know. I'll try to repeat that thing. So this is what I was talking over here. My data will go to a map phase. So in the map phase, my data would go one by one. So this blue block will come to the map phase. Map phase will produce key and value pair, something like this, blue color and the count of the color. That goes to your prehash phase. Prehashing or hashing basically helps me in sorting the data. So the blue color hash value is 44, and this reducer is taking care of hash value is 44. So I am definite enough that all the blue color keys, irrespective of the fact from which mapper those keys has been created, that will go to this blue color reducer. And this is the beauty of this whole program. I'll get something like this in my reducer function, and the reducer function, all I have to do is just count the values of the key and produce the output. And this is how I can achieve something like this, counting the colors in the program. Now, any questions on this PPT before I go ahead? Okay.
Hey,
Yeah.
hey, so if I have to just keep that slide open, so if I have to summarize what you're saying that there are essentially two functions. The mapping function will end up in resulting in a hash code where it takes.
Sorry to interrupt. Mapper function will just produce key and value pairs.
Okay, so the mapper function will just produce the key and value pairs of the blocks of data that it is mapping.
Yes.
And then we have the shuffling and the sorting function, which will take those key and value pairs
and ensure,
and then it will do the key. Well, they take the keys and the values, and then it will basically give you a reduced set of data to work with. Is that in a nutshell what this slide is trying to say?
No, let me try to rephrase it. So this mapper function gets an input from your raw data. Raw data is somehow you do some processing on that raw data, create key and value pairs what you want them to look like. You produce those key and value pairs. So in this example, as we are doing the counts of colors, we produce key as color and count as 1. because we are reading one by one color from the raw data and producing there's an output of the map function, and in between this whole blue color box is hidden to you. You will not be looking into this box in your normal program, but what I'll talk about that thing also in how this hidden function works at the backend, and we can change the code of this hidden functions also. So this hidden function, the sort and shuffle phase basically creates the hash value of your keys. So hash value is nothing but a concept by which I'm hashing my key and ensuring that the reducer which is taking care of those hash values or the bucket of hash values, and ensuring that the corresponding key is going to the correct reducer which is taking care of key that kind of key. So in that case, if this reducer is taking care of blue color keys, if this reducer is taking care of blue color keys, all the blue color keys, irrespective of the mapper, see all these blue color keys are coming to this reducer. So in this way, I'm ensured that the count which I'm producing from this reducer is not half count. So if, for example, say 10 of the blue color keys have come to this reducer, 10 of the blue color keys could have come to this reducer. If that could have been the case, then this reducer will produce an output of blue color 10 and this reducer will produce an output of blue color 10. But what I wanted is a consolidated output of all my colors in my raw file. So Pradeep, I'll just put it on mute. It's echoing a lot, and I'll just unmute you after I'll explain it again. So this sorting and shuffling phase ensures that your corresponding key, which should be taken care by the corresponding reducer, reaches that reducer. In this example, we are assuming that there's a dedicated reducer for each color. But in practical scenario, a single reducer could take care of all the 3 keys, or there could be 10 reducers which will be running and taking care of hundreds and thousands of color. So a single reducer might handle more than 1 key. There could be a reducer which might not get any key. There could be a reducer which might get all the keys. So there could be different scenarios. But in this example, for the simplicity, I'm showing 3 reducers for each color, and each reducer is getting the key which it is associated to this reducer color, which I have displayed in this example. And this is the way a simple Mapreduce program works. So I'll just unmute you again. Does that clear?
Yes, it makes sense. Thank you.
Okay, sure. So Jignesh, I'm just coming to your part. What part of the process, map, sort, shuffle, reduce, etc. is a part of Hadoop framework, and what part we have to write in Java program? So okay, that's a good question, Jignesh. So in the Java program, you have to just write map and reduce phase. Everything else is transparent to you. So all this blue color box, hashing, sorting, all these things is automatically done for you. What you have to do is, in the Java code, you read the data. Data is automatically read for you. You don't have to worry about reading the data also. You have to just write your mapper function with the pre-assumption that your data would be read by somehow at the backend to you, and you will get the data. In the mapper function will somehow create key and value pairs based on what kind of processing you want to do. And you will produce those output from the mapper function, and in the reducer function you will do the combining or merging kind of things and produce the combined or merged outputs or the analytics over the data. Basically, somehow when you are running a Mapreduce program, you are doing or calculating some analytics over the data, or you are filtering the data, or basically processing the high amount of data. So this mapper and reducer phase, it is beautiful enough to adjust any kind of data. You can adjust, or basically any kind of data can fit over here in a map and key value pair. Okay, Jignesh.
Do you get to define your own key value pair? I mean, so for example, here you have said that the key is blue and the value is 1, but I can take that same picture and come up with a totally different key value pair. So do you, as a part of writing the mapping program, so you get to define how you want to define the keys and values for your data?
Yes. So we define the key and value, what was the key and what was the value in the map phase, and if some processing need to be done, we do that processing in the map phase and send those things to the reducer phase and reduce or do the combination or analytics or statistics over those key and pair of values what we have received in the reducer and produce that thing as an output to the SDFS board. That will be more clear to you in next in further more slides, but for a time being, yeah, that's correct as well. That's correct. Although that's not 100% correct, there's other complexities also which we'll be discussing in further on slides. But for this slide, yeah, that's the correct assumption.
For the mapper phase, there's no concept of having unique keys, right?
No.
Keys can be duplicated.
Yes. So for this slide, that's a correct assumption, but there's other complexities also which we'll be talking about. But in this slide, if you understand that we produce somehow key and value pair from the map, and that goes to reducer phase. Reducer receives something like key and pair of values and produce an output based on what we are trying to achieve. And that's pretty much done for this slide at least. There are other complexities, how the data is read and how the key and value pairs are created. Shall I move ahead? Okay, everyone says yes. Okay, let's move ahead. So this is how it happens. Here I'm just trying to picturize it. So these keys keep on going to a corresponding reducer, which will get the key and value and pre-hashing thing, and it keeps on counting it. So this is a hashing function which I'm trying to define over here. What happens in hashing? The bucket which is taking care of those hash values will be basically the keys. Keys will be going to that hash function, hash bucket. So they will keep on running. I'll just switch over. So I'll just come to this part. So I think Pradeep, you had a question. So there are two complexities which I'm trying to introduce over here. 1 minute, I'll come to that part. Let me show you one more example. Okay, let's see this example. Then I'll go back to that thing, and we'll add further more complexities of to what Pradeep you were asking. So here what I'm doing is I have to count the apples written in my file. I have to count the distinct words in my file or distinct fruits in my file. So what happens is the data is read from the file and so these are the input files which I am reading, and the map function is recalled for each record in the block. So say these are 2 records these are 2 blocks, sorry, which I'm reading for this file. So a mapper would be created for one mapper would be created for this thing, one mapper would be created for this thing, and one record will be read from this, and mapper function will be called for this record, and then this record will be written and the mapper function will be called for this record. And when this mapper function will receive this whole text as the data, what mapper function would do is it will produce key and value pair something like this: apple, 1, orange, 1, mango, 1. Now Pradeep, that would make more sense to what you were asking. Now we have created our own keys and our own values because we wanted to sum the different fruits available in or written in this file. This go to sort and shuffle phase. Sorting phase sorts the whole data based on the key, and in between hashing applies, and that ensures that the corresponding reducer will get the keys which it's reducing. So here say they are different reducer for each key. So this reducer will get apple comma 1 comma 1 comma 1 and will basically do a count of the values and produces that thing to the final output. So here we create our own key, something like this, and in the reduce side we get those key and pair of values, and we do a summing or grouping or whatsoever we want to do with those values, and we produce the output. Does that add one more step to your understanding what you have understood in the previous slide? Okay, Jignesh says yes. Pradeep? Yes, okay. Okay. I hope Vikram, Emily, I think is not there. You are following up. I'm getting a lot of questions from Jignesh. I'm getting questions from Pradeep, but Pawan, Vikram, I'm not getting anything from you. Pawan says yes. Vikram says yes. Emily, I hope you are away. If you are there, you can just ping me up. I'm just assuming you are away. So this is what I was talking over here. Map function is before that there's one more file. Okay, so when the data is read from your file system, that data is read in key and value pair only, and that is being given as an input to a mapper function. Mapper plays on that key and value pairs and produces its own key and value pair. So in the previous example we have seen the mapper has produced key and value pairs as fruit name comma 1, value was the count of that fruit, and those key and value pairs which are produced from the mapper goes to the reducer as an input. The type of this key will remain same for this reducer. It cannot be changed because what is being produced by the mapper is consumed by a reducer. And but in between sort, with the beauty of in between sort and shuffle pair, the values are created a list so that a single reducer function is called once for each key of the mapper. And reducer at the end produces your key and value pair. Any doubts? Okay. Okay. I'll again come back to this part. So here, what is the key and value pair which has been passed to mapper phase? That would be a question, I think, in your mind. So there are in between classes or things like that. I'll just talk about them before going ahead, and then I'll be talking about those things in detail. But I'll just talk about that thing a little bit. I'll just open my Excel sheet again. Now I hope you can see my Excel sheet again. Now I'm just assuming single is okay. Let me show you the complexity of a split also. So say my file is something like this: blue comma okay, blue comma red comma green. Red, blue, and so on. This is how my file is. I have to produce key and value pairs now. So what I'll be doing is I'll be reading line by line from this file. This is the default reader which is there in the Hadoop world. So I'm just talking about the default reader. I'll tell you, I'll be talking about this thing in detail. But let me explain you how the key and value pairs are created and sent to your mapper function. So mapper is a function which gets some key and value pair and produces some key and value pair. Reducer is again a function which gets some key and value pair and produces some key and value pair. So what happens is this okay, so this is 1, this is split 2, this is split 3, this is split 4 for each blocks, and these blocks are similar to this almost. And I am doing the color count only. So what happens is I read I read the default separator of a record in the Hadoop word is /n, that is new line. So that is the default one. Everything is configurable. Everything we can set in our Mapreduce program. Everything we can set in the configuration files. So I'm just talking about the default things which happens at the backend for you. So the default way this would be read something like this. When this data would be read and passed to your mapper function, the keys would be something like this. I'll add one more thing over here. Insert input to mapper. So the default key which will be created by your default file which reads the data for you, or the input function which reads the data for you and which passes the data to the mapper function is the text, and the key is nothing but the offset value of the line of your data. So it would be something like this: 0, comma. Sorry. It will be something like this. Sorry. What this 180 is, this is the, okay, I'll just add one more column over here to reduce the complexity. So this would be the input, and this is equals to this is your key. This is the value which has been passed to your mapper phase. The thing which I am producing as the key, these numbers are nothing but the offset value of your line. What is the offset value over here is the default reader would read it something like this. Key would be the offset value, that is the starting location or starting pointer of this block or this record. So this is 0, which is starting from here. Then it is 90. I'm just assuming these are the 90 characters. So this is 90, and then I'm assuming in the previous record there were 90 characters. So this is 180 and so on. So this is how your data is read and these inputted to your mapper phase. So these are the keys and these are the values which will be inputted to your mapper phase. So when the mapper will be called for this blue, red, green, the first record, the mapper will produce something like this. And that will then go to your sort and shuffle phase, and sort and shuffle will send you a reducer phase and so on. Now does it make sense, one more step, how that mapper gets key and value pair, and how those key and value pairs are used by the mapper to produce another key and value pair, and how those another key and list of value pairs are used by the reducer and produce something as a tangible output to you? Jignesh says yes. I think that was long back, yes. Pradeep said yes.
Hello, Meeraj.
Yeah.
So I have a question though. Can you hear me?
Yes, I can hear you.
Okay. So I have a question though. Okay, in this case, the way you're doing the way you're breaking up the data into the key and value pair, you kind of use the the offset as the logic. You said that I'm going to use offset, and then based on that I'm going to count it and do that, right? Now so to me that is how you analyze and how you come up with the key and value pair. That could change on a case by case basis, right? I mean, for each and every different data that you want to analyze, you would have a different type of an idea on how you want to analyze that data. Are there any predefined set of functions that comes with Hadoop as a part of how you want to map the data that you can just use?
Yeah, Pradeep will be talking all about them. There are a lot many which are default readers for you, so these are the default readers. So this is a default reader which I'm talking about, text input format. There are others also which you will be looking into them, but I'm trying to come up slowly and slowly to those points. So yeah, definitely there are a lot many others, and you can create key and value pairs based out of a data based on predefined or pre-inbuilt classes in the Hadoop world. And you can directly use them, configure into your job configuration and use them, and that will create a key and value pair for you, which will be input to your mapper phase based on your data.
So that was, yeah, so that was my question is that, I just wanted to establish two things which I think you kind of confirmed.
Yeah.
So number one is that mapping your data into key and value pairs, that's almost a figment of your imagination, meaning that you could come up with so many different ways to map them into key and value pairs depending on how you want it to. And number two, Hadoop has some of the most common pre-built or predefined algorithms that people have come up with already built as functions that you can use. So you don't have to reinvent the wheel, correct?
I agree to your point, although there are a lot of things which have been developed, but most of the things which you would try to do or how you would want to read the data, you would be definitely, there would be something available as a default class for those things. But if you have to achieve something specific, yeah, you can find a lot of things which have been developed, but that there's no great development in this world because there's a new technology and it's still in an evolution phase. So you could find most of the things, but I won't say you can find all the things.
No, I understand. That's what I'm saying. But if again, this goes back to, like, I mean, I know for text analysis and numbers analysis, there are, I'm sure there are a lot of pre-built classes, but then when you come to things like voice files, or when you come to things like picture and images and analysis of those, I'm sure there are some algorithms, but they're not, and somebody can easily come up with something new. So in those cases, then they can write their own analysis to look at the data and then come up with a key value pair, right?
Okay, I got a confusion. Okay, let me try to explain that. Okay, so you are saying that if you have to process something other than text files or unstructured data kind of thing, so see, what Hadoop helps you is in doing the parallel processing. Hadoop is a framework which helps you to set any kind of data. So even if you are processing your video file or voice file or any unstructured data, you are using the parallel processing power of Hadoop. So, but at the back end, when you are processing that file, the way you are processing that file outside Hadoop, you will be using the same logic. You will be reading that audio file or video file with some audio reader or video reader, audio codecs or things like that. So your mapper function, while processing that data, would be using only those codecs and splitting your file or whatever you want to do with that file. Or if you are converting that file to text, your mapper function will be using those codecs. Parallelly, the hundreds and thousands of mapper would be running on your hundreds and thousands of video files which are lying in your data, and which doing those tasks. So this key and value pair helps you to fit out any kind of data in it, and this whole framework helps you to parallelize this whole process. And you as a user, you have to just define only these tasks: how to read that data, if your data is in an unstructured format, how to convert that data to a corresponding key and value pair, what I want to achieve with my data. So say if I want to convert my audio files to some text file, and then I have to filter out what are good words set for Amazon. So I as a user would be inputting key as the video file ID and the value as the video. In the mapper phase, I might be converting those video using the codec from video to or voice to text. that would be sent to the reducer, and reducer or there might be one more Mapreduce phase in between this whole cycle. The another Mapreduce phase would be reading the data, doing some this thing, what do you call this, sentiment analysis on that data. So based on the words available in that in a single line, it will just look at whether sentiment of this line is negative or positive, and whether this line contains something like Amazon. So that data would be filtered and sentimented, and the keys will be created for each sentiment, and that will go to a reducer phase, and reducer will just print the count of positive sentiments and negative sentiments. So you as a user have to process the data how you're processing till now. This whole framework gives you a beauty to do a horizontal scaling of a processing and fit in any kind of data.
Right, but to your point, what you're saying is maybe for voice analysis, you may not have just one cycle of Mapreduce, but you may have 2 or 3 cycles of Mapreduce.
Yes, you can create workflows. Yes, you can have even 10 cycles of Mapreduce. So you can create workflow of whole Mapreduce chain to do the processing.
Right. Okay. Thank you.
Sure. So, guys, any other question? Okay, so this is how your key and value pairs are created, passed on to your mapper phase. Mapper then processes that data, process the key and value pair on which you want to play with. Those are sent to a reducer, and reducer then does the magic for you. Okay, let me go back to the PPT. So now I hope you understand map gets a key and value pair, or produces a key and value pair. That key and value pair goes to a reducer. There could be a step where you don't want a reducer, like in the previous example which I was saying. My mapper is converting that text to that audio to text, and filtering out only the lines which contain a word called Amazon. So in that case, I don't want any reduce thing need to be done on this data. So I'll set the reducer task to be 0, and from the mapper I am just producing the text which contains word called Amazon. So there could be scenarios where you are not producing you are not doing any reduce phase. So those things are going configurable. We'll see about those. We'll see those things. So in the previous example, which I've seen for the word count or the fruit count, the input was line of text. The output was the word and the value. The reducer got the word and set of counts, does the sum on those, and produce the output for you. So this is the word count for this whole thing, for this example which I've shown you over here, where I'm just doing the different words in my file or the different fruits in my file. So this is a simple word count program for this. So your mapper as a class need to extend the mapper interface, and it has some function called map function. That map function will get some key and some value, and will produce some key and value pair. So this context.write which basically produces the key and value pair, which is defined over here. So this is what map produces. So what I'm marking in the green color is what map is getting as an input from the file reader, and what I'm highlighting in the purple color is the output which has been produced by this mapper as a key and value pair. So this mapper gets something as key and value pair, produces that key and value pair. So here this key and value pair, the type of this long writable is same to this, and this text is the value. So I get this thing. What I did is, as I get this text, apple space orange space mango, I try to split this text into by space, and for each word, which I have tokenized in over here, I am producing the word and the count. That is the individual word and the count as one. So this is what I am producing from this map. So this map is producing something like word apple, comma 1, orange, comma 1, mango, comma 1. And in the reduce phase, what I am doing is I am what is the output of the mapper would be the input of this reducer. So the key of this reducer would be text, as the key of my map function was the word, that is the apple or things like that. So this is the input key for the reducer, and the values are int writable, that is the 1, 1, that is the list of values, and values were int. And this reducer will produce something like text and the int writable again. Don't worry about this int writable, what is int writable and text. I hope you understand just understand the English meaning of these words. I'll go in the complexities of about these Java words. So this will produce something like text and int writable, that is the sum of the total counts of those words in my input file. So what here I'm doing is I'm iterating from all the values which are available in the reducer, summing them up, value.get, and summing them up, and producing the key, that is my word and the sum. And at the back end, so my reducer got something like this key and list of values. So I did sum of all these values and produced that output. And I'm just saying context.write, that is producing the output, and that will be returned to the SDFS, key as the apple and result as 4. And to call this mapper and reducer, I have to set this, I have to create the configuration things to run this mapper and reducer. So the configuration is done in your main program. So in the main program, I'll talk about in more detail about this thing, but I'm not throwing all, I am just trying to go slowly and slowly. So I'm creating a configuration. I'm giving this this whole program as some name. So I'm just giving it I'm giving it some name over here, and I'm giving it my map class name, that is map.class, my reducer class name, that reduce.class. Here I'm just given the reducer class, but I have to give the real name. So that was word count map and word count reducer. So I have to give those names, and these are the default ones. Don't worry about them. These things. And then I have to just give on the input file location where from my mapper would read, and the output file location where my reducer will produce an output. So I'm setting the output path and input path, and I am just submitting the job. So this job now knows which mapper class is associated to this job, which reducer class is associated to this job. And when the logic need to be really run by our task tracker will initiate a JVM for this mapper class, will run that mapper class, and while it's running that mapper class, it will get the input from this location, and it will be running it only for some particular block of this input, and that all information is passed to it. And now I hope you understand how that is passed to it. And the output from the reducer, when the reducer is run by the task tracker, the output of that reducer is then produced to your SDFS board. So does that sound interesting, guys? I'll talk about the other complexities in this program. We'll try to run this also, but I'm not going. I'm just giving a glimpse of how a simple Mapreduce program looks like. Pradeep says good. Vikram, Jignesh, Pavan, Emily I think is away. What is, okay, Vikram says what is word count class? Jignesh says yes, good. Okay, Vikram, I'll just come to you. Pavan? Okay, Pavan, we can, okay, Pavan says we can proceed. Okay, so Vikram, what is word count class? No, word count class. Okay, you are talking about this. So, okay, I'll just talk about it. So this is what I was showing you on the slide. So here word count class is nothing. That is your that is the class which need to be run in a jar, which I'm setting over here. So here I am setting the word class name, word count class. So this is the class which is containing my main function. So I'm just setting it, which need to be ran by your job tracker to find out different things about the program, configuration about that program, and the mapper and reducer phases would be ran by your task tracker. Vikram, does that sound good? Okay. Okay, so let's try to run this simple Mapreduce program, and then we'll talk about in detail about Mapreduce program, different things about Mapreduce program, partitioners, combiners, and things like that, and how the input format works, output format works, how this all input thing works, how this all key and value created for input and things like that in our next class. So again, guys, we can create a jar out of this program. I'll talk in detail, and then in the next class how to again create the jar. By that time, you just try to download these all softwares, try to open them up, just play with them a little bit, and then I'll again explain you if you are facing some issues while installing these softwares or opening them or things like that. So to create a jar, I can either use Maven, or I can just say file export, I was saying you previously, and I'll just click a runnable jar, and next I'll draw in the drop down, I'll just choose the main file name, the file which contains my main function. So in this case it's word count, so I'll just choose that file export runnable jar. Next choose the word count, and package the required libraries to generate jar, click finish, and in the browse I'll just browse the directory where I want to put this file. Okay. So when I create this jar with the help of WinSCP, which is again shared in the shared drive, just a minute. So which is shared in the shared drive WinSCP. If you double click, if you just download it and click it, it will open something like this. You have to log in it with the Hue and Hadoop, and you can the jar which you have created at the left hand side is the Windows console. The jar which you have created, just copy it to your Unix console, and then open your putty. Again, it's shared over there, putty.exe. You double click it, something like this will open for you. Give an IP 127.0.0.1 port 222 to ensure to change this port from 2222 to 4 times 2, and press OK, and it will ask you for the username and password. Yeah, Jignesh, you can drop off. We'll be dropping off in next 5 minutes. You can drop off, and if you face any issues installing, just let me know. So once you open up your putty and log into with Hue and Hadoop, you can run your Hadoop jars. So let's try to run that Mapreduce word count program, and then we'll wind off. So so guys, if can we prepone this class of 10:30 to 9:30 or 10? Is that fine with everyone? I think someone from India also wanted to join this class, and it becomes a little late for them. And I have to just give the class name which I want to run. And the input and output file. So I'll just give some input file which I want to, on which I want to count words. So I'll just see if there's any input file which I can give to this program. Okay, so let's use this file only. Use DB input. UDB. Slash text, and output as, I'll just produce the output over here. I'll just leave this directory. I'll produce an output over here. So I'll just give you user DB and slash. So this is the command which I was discussing with you people previously. Hadoop jar name. The class name is required if I'm not creating the executable jar like the way I've just created right now. This is a Maven created jar, so I have to just give the fully qualified jar name. The input directory, I'm trying to count the sum of all the the count of distinct words in this file, and producing that output to the issue DP output. Pawan, this syntax is there in the Java file, so I've shared this. I'll be sharing all code with you, and the syntax to run it. If you open any of the Java file which you want to run, at the bottom of the Java file, this is commented. That this double slash says that this thing is commented. So you just copy this thing and run it. Put it on the command prompt, and you will be able to run it. So just copy it and right click on the command prompt, and that will be pasted on the command prompt, and you will be able to run it. All you have to do is to just change the input and output path based on the input and output files which you have based on the input file which you have created. And this jar is also copied in the shared drive which I was discussing over here. So if you don't want to do all this process of creating the jar, all you have to do is I'll be sharing this folder called code. This is a Mapreduce snapshot.jar. So you just put this jar into your sandbox, and you can just try to run these programs. So as I was saying, shall we prepone this class by half an hour, 1 hour? Is that fine with everyone, or do you just want to stick with this time? So see, this is ran. It also gives me the statistics about the job it has ran, the number of bytes read, return, operations, runs, and all those things. Let's look into the output folder which is created. So there'll be an output folder. So see, these are different words and the counts corresponding to that word. So these are distinct words which were in that file, and counts of those words. So this was commonly used word. This occurred twice. This was a commonly used word, and so on. Make sense? Sounds interesting, or actually? Okay, Pradeep says yes, sounds interesting. So, any questions from anyone before we wind up? We'll talk in little bit more detail about map and reduce part. I'll talk about how the input files, other things looks like, how this all key and value pair created, what is the logical data distribution, what is basically logical data distribution, or what is split basically is, and things like that in our next class. Sure, Pradeep, you take your time, try to install them. If any one of you is not able to install them, we will discuss those things in our next class, and we'll see all those things. So our next 2 sessions will be dedicated to this Mapreduce word. We'll try. My objective would be at least each one of you is able to run at least one Mapreduce program on your laptops. If you are able to run that, that is very good, and I'll try my best to help you in installing and doing all those things. Oh, Pawan, I forgot to pass your information about the Hadoop administration course details. I'll pass those details to the admin team, and then someone will get back to you on Monday. I forgot to pass the details. Sure. So I hope any other questions? Okay. Sure, Pradeep, you can drop me an email on my email ID. Okay, sure. See you next week. Sure, Pawan, you just try to install them. If in between you can face, if you face any issues, we'll discuss in the next class. So thanks everyone for your time, and have a nice day. Bye bye. I hope you enjoyed it. Thanks for your time.